Well, I'm going to walk you through some stream development, and we'll start out with some of the theoretical, and then we will go into the actual, and I'll actually show you an example on a little small creek out by Aurora, Oregon. It's about 6.5 miles long, and it drains an area of 5,440 acres. This is RyanCreek. It flows north up to the Willamette River, where it dumps in at its mouth. And we'll look at it start from its headwaters, a small lake or impoundment just south of Champoeg Park, as it flows north all the way to its mouth. And you'll see it go from a straight, rapid moving stream all the way to an oxbowy, even some cut-off meanders, and all the way to the mouth. So let's walk you through it. Here we go. We're going to look at stream development from a young stream all the way to a mature stream as it goes from its headwaters all the way down to its mouth. So let's take a look at a young stream to begin with. Young streams tend to be very V-shaped, and the gradient is pretty extreme. The water has lots of energy, and it just cuts right on through. As you go down farther on the stream, you'll start seeing curves, or what some people might call meanders. You'll start to see a floodplain start to develop when the stream floods in spring and fall and winter. You also may start to see small levees starting to develop. This is sediment and debris left over from each flood. And as Don McLean said, you can drive your Chevy on the levee. Well, only if the levee is mature and big enough and dry enough. As the river gets farther down along its course, you'll start to see extreme meanders, and you'll start to see deposition or sandbars starting to form on the inside curves and erosion on the outside curves. The floodplain is still growing, and the levees are getting bigger as we go farther and farther down the river. Eventually you'll get oxbows. These are extreme meanders. And what do you think is going to happen next? Well, let's take a look. Well, is that what you thought? Yeah, that's what happened. You'll get what's called a cut-off oxbow. And this is the river trying to straighten itself out so it can start cutting down and increasing its gradient. Eventually, you'll get oxbow lakes, and then these oxbow lakes can fill in with sediment, and they become marshes and wetlands. And that takes you from, hopefully, from the start of a river, or the head of the river, all the way to its mouth. Here we are near the headwaters of RyanCreek. As you can see, this is a very active, young part of the creek. It has pretty steep gradient. The water is rushing along in a very straight path. Because there's more friction at the edges of the creek and at the bottom of the creek, this causes, and it's moving faster in the center, this will cause energy gradients, and this will cause the river to change. And this will be a very dynamic system right through here because you have so much energy. And these useful characteristics of being straight and rushing along will change rather quickly. Here we have a meander or curve, and as you can see, it is eroding on the outside and depositing on the inside, making a nice little point bar right there. Here we have a cut-off meander where the river has been eroding on the outside curve and depositing on the inside curve, and a point bar was developed. Then, as time has gone on, the river attacked the point bar and literally cut across the meander, and it's now starting to straighten out the river again, as you can see. Here's the floodplain of RyanCreek, and this acts like the shock absorber during flood times of when we have high rains or snow melt. And as we go across, you can see again the floodplain on the other side of the river. And very important areas, riparian areas, and not a good place to put houses. Sometimes when a creek comes around a corner like it is here, you'll see what happens. The velocity will slow down, and all the things that the river is carrying, like dirt and sediment, but also things like branches and parts of trees and blowdown and things like that, like during a storm event, will also lose its velocity as it makes the turn, and all that stuff will be dropped as the creek loses energy, and you'll get what's called a rack heap. And this is a big rack heap and a severe blockage of the river. Here we have a beaver dam, very common here on small creeks in Oregon. There's been a lot of research up in Canada where they've taken out beaver dams and trapped out all the beavers. Biodiversity drops, the highs and lows, the extremes of the river are increased, and it's very detrimental to anadromous fish runs like salmon, trout, steelhead. And they do a wonderful job of also filtering out the water. They capture sediment, and the water coming out of the spill out of a beaver dam is much cleaner than the water going in. Here we are near the mouth of Ryan Creek. As the gradient flattens out and as you near the mouth of a river will show its old age characteristics, probably in its strongest form. Here we have a meander, and as you can see, you have a point bar building on the inside of the curve and a deepening and erosion on the outside of the curve. And here we have the mouth of Ryan Creek, where it dumps into the Willamette, a much bigger river. And as you can see, there's almost no gradient at all. The river is moving very, very slow at this point. The end? Well, not really. The water that flows from Ryan Creek then flows into the Willamette, which then flows into the Columbia River, and eventually flows to the ocean, where it will be evaporated, turn into clouds, and then precipitate, and the cycle will go round and round and round. And by the way, did you see that otter swimming over the top of the beaver dam? Now that's cool. What a wonderful place we live in.